All right, let's do a little simplifying with some multiplication and division. Remember, when you are multiplying, what you're trying to do is factor and cancel. That's usually the name of the game. And when you're dividing, it's basically the same thing. You're just trying to keep, change, flip, and then do the same thing. All right. So let's look at this first question. What you want to do is look at every single piece of your fractions and figure out what can I factor? What can I do? The kinds of factoring you're looking for are trinomials, to where you are breaking them up into two sets of parentheses. All right, like the factors of the last number that I had to give you the middle term. The other thing would be some binomials. Now, when you have binomials, you really have two different options. There's a difference of squares, so like x squared minus 25, or there could be something with just a greatest common factor, like 3x plus 9. There are two different things that happen when you have binomials. So let's look at what we've got here. On the top left is just a 1, so that one's no good in factoring terms. But on the bottom, you have a 6n plus 54. Now that's a binomial. It's not a difference of squares because it doesn't have one squared term and then just one number. But it does look like one of these questions to where we could have a greatest common factor. So what's the highest number that goes into 6 and 54? It's going to be 6. So we're going to factor out a 6, see what's left over. It'll be an n plus 9 times 6 is 54. This is a multiplication problem, so we're just going to leave this as times, and we're going to keep going. Right now, top right is a trinomial. That means it's one of those where you figure out what multiplies to be 18, but adds to give you 11. So what are the factors you need on that one? Should be 9 and 2, and everything's positive, so plus and plus. The bottom right, that's a regular old 10. This one doesn't have a variable on it, or a regular n. And this is a 10, but no variables or anything, so we're just going to leave it just the way it is. Can't do anything with that. All right, so what you want to do when you get here is you look at this fraction, you look at this one. There's nothing we can cancel on top and bottom on just these fractions in and of themselves, but there is an n plus 9 over here and an n plus 9 over here. So those are gone. I don't see anything else that will go, so let's just go ahead and write what we've got as an answer. On the top left, remember when you multiply fractions, you multiply straight across. So 1 times n plus 2, that's just going to be an n plus 2. Now, if that was a different number, like a 3 or 7, then we would have had to distribute that through, but it wasn't. So we're okay to just say n plus 2. On the bottom, we've got a 6 and an n plus 10. Now, I said we would have had to distribute it through, but honestly, this is okay just the way it is. I know you see 2, 6, and 10, you think, oh, all this is divided by 2. But the thing is, with these terms, these expressions, you can't just simplify half of them. Like if I just simplify the 2 and the 6 and the 10, that's not the entire expression. Like I would have to have a variable, or excuse me, a number on the variable to also simplify if I was going to do that. So we can't do that on this one. We're going to stop here, and that's all we can do. Alrighty. So if you're unsure if it simplifies, it'd be better just to leave it the way it is than to simplify and it not be something that actually is doable. Okay. Now, a question like this is one that was missed a lot on the last quiz we did. And I'm not real sure why. I think it's because it's an atypical question. It's just mainly reducing exponents, and it just kind of threw y'all for a loop. But notice this is division. So this is a keep, change, flip question. So that's the first thing we're going to do. We're going to keep the first fraction. We're going to change the division to times, and we're going to flip this second fraction to where now the numerator is denominator, vice versa. All right. So here's where a lot of people were getting confused. They didn't really know what to do. There's a couple options you have. I personally think it's better just to get these together as one fraction. There's not really anything you can do except reduce some things over here with maybe some things over here. So I suggest just multiplying everything together straight across. There is no cross multiplying in any of these questions. I don't know why people start thinking that when they see fractions, but that does not happen on these. So that's 35. And then let's just bring all this stuff over. All right, and then multiply your coefficients here. That's 8. And then bring all these things over. All right, so in a question like this, all you can do is reduce exponents or coefficients. Now, 35 over 8, it doesn't reduce. You can put that in the calculator as a fraction. It will not reduce. It'll spit it back out. All right, but what I do want to do is focus on these variables. I see a p to the third and a p. Now, if that's just a regular old p, remember that's a 1. If you think about expanding that out, you would have 3 p's on the top of that fraction and 1 on the bottom. That's what p to the third means, right? So one of these p's on the top would cancel with one of those on the bottom. So what would be left over would be p squared on the top of the fraction. So that's what we do with that. Now here's an m squared on the bottom and an m to the first on the top. So that's an m on the top, and that's 2 m's on the bottom. Again, m on the top goes with an m on the bottom. An m is left on the denominator. So that's where it stays. And then lastly, you have your n's. You have n to the fourth on the top, n squared on the bottom. I hope now you can see that both of these n's would cancel with 2 of these, leaving with 2 on the top. So wherever they're left over is where they have to stay on the fraction. So that would be the simplified version of those two fractions.